We are going to look at contingency table. We are also going to learn how to compute the marginal and conditional percentages. We're also going to learn how to determine if there is an association between two categorical variables. And then we would also talk about the Simpson's paradox. So in previous chapters, we know that we have two types of variables, which is the categorical variable and then also the numerical or the quantitative variable. We've also looked at how to use frequency and then the relative frequency to also um, do some calculations and the types of graphs we can also use to display categorical variable. Here we are going to look at two categorical variables simultaneously. And so, for example, if we have, say, gender and eye color, we want to know whether there is an association between gender and eye color. So the categorical variables here are gender and then eye color. And so to be able to do that, we can organize this in a table, and that table is called contingency table. So essentially, a contingency table, it just displays the count for two categorical variables. So this table here is an example of a contingency table. So looking at this table here, I want to ask, what are the categorical variables here? Who would like to help us?
If the person is a smoker or not, and like the amount of education they have.
Exactly. Is that okay? So you can see from here, the column here, this shows whether the person, so this is smoker and non-smoker. So that is for the smoking status, like he said. So that is for the column. And then we can see the other variable here is this, which is the level of education. So those are the two categorical variable. And then this is the contingency table. So for example, when we look at the number 32 here, the 32 here stands for somebody who is a smoker and also in high school. Is that okay? Or their level of education is high school. When we look at a 72 here, it's somebody who is a non-smoker and they have 4-year college level of education. So it is very important that you understand the contingency table. So the first thing you have to think about is to ask yourself, what are the variables? And so the variables here, you can see there's a contingency table. So it's smoking status and also level of education. And smoking status is on the column, you can see. And then the level of education is the row. And also, you also have to understand that this 50 here stands for the total number of smokers. Is that okay? And so this 200 here stands for the total of everything in the table. It's very important to understand the contingency table. So you can see the row stands for the categories of one variable. The column also stands for categories of another variable. So there are two categorical variables here. And then we can use contingency table to display the count for the combination of these two categorical variables. Now, we are going to learn how to do some computations. we are going to learn how to compute the marginal distribution and also the conditional distribution. So for marginal distribution, it represents the frequency distribution of one categorical variable without regard for other variables. So for example, we can find the marginal distribution of smokers. We could also find the marginal distribution for level of education. It is very important that you learn how to compute marginal distributions. You would be tested, and it's also good for your education. And also for conditional distribution, it shows a distribution of one variable, given that the other variable is fixed at a specific value. We are going to do examples of this, and then you are going to understand how to do these computations. And so what I want you to do now, we are going to learn how to do these computations. But before we do that, you have to be able to understand the problem. So I'm going to give you a minute to read the problem. So before we proceed, let's try to answer some problems. So we've already talked about these who, what, and why in previous chapters. Now, who would help us? So I have your names yet, so I'll be calling you randomly. So you tell us what you think. So what is the who here? Is Kiana here? How about Joseph? Yeah, Joseph, what is the who? Do you all agree with that? So the who is the 200 adults, right? How about the what? Sydney. And then exactly. So it's the what is the what? The smoking status and also the level of education. Do you all agree with that? Okay. How about the when? Jenny. You all agree with that? Okay. How about the where? Charlotte. Is Charlotte here? Nia. Ashley. Mhm. Yep. So the only information we have is the supermarket. Is that okay? Good. How about the why? Mhm.
See if there's a correlation between smoking and the level of education.
Yes, to see if there is an association between smoking and level of education. And then how? Charlie. Aiden. Mhm. What do you think? How? So the only information we have is that the adults were just asked. Is that okay? That is the only information we have. We don't know whether they gave them a sample or whatever. All we know is that they were just asked. Is that okay? Now, let's get to 2. But before we get to 2, let's try to, let's do 2. So 2 says that what percent of smokers before we get to 2, let's try to find the marginal distributions. So marginal distribution is just trying to find the percentage of one variable without the regard for the other variable. And so let's try to find the marginal distribution for the smoking status. So for smoking status, we have either you are a smoker or a non-smoker. Is that okay? So how many smokers in total do we have? You all agree the number of smokers is 50? You can see from here. And so for smoking status, you write down smoker and then you write out non-smoker. How many smokers do we have? 50 divided by the total, which is what? 200. Is that okay? How many non-smokers do we have? 150 divided by the total, 200. You can see the way I did that here. So you see, smoking status, we have smokers. 50 divided by the total, that represents 25%. Non-smokers, they were 150 divided by 200. That represents 75%. So this is the marginal distribution for smoking status. And then let's do the marginal distribution for level of education. We have high school, 2-year college, and 4-year college. Is that okay? Write that out. Is that okay? So each time you're asked to find the marginal distribution of a variable, go to that variable. So for example, with smokers, we have smoker and non-smoker. Write that out. Is that okay? Level of education, we have high school, 2-year college, and 4-year college. Write that out. Then you come and ask, how many total of high school students do we have? Who can help us? 93. 93 divided by what? The total. Is that okay? How about 2-year college? 22 divided by what? 200. How about 4-year college? 85 divided by what? 200. This is how to find the marginal distribution of a variable. So you can see from here, you see education, I write high school, 2-year college, and 4-year. So the first step is to look at the variable and write out what it has. So for example, smoker and non-smoker. For education level, we have high school, 2-year college, and then 4-year college. So this is the marginal distribution of smoking status and the marginal distribution for education level. It's very important you know how to compute that. Let's get to the next question. The next question says that what percent of shoppers were smokers with only high school education? What percent of shoppers? It's very important you understand the question. What percent of shoppers were smokers with only high school education? So the question is, what percent of what? The percent of what? Shoppers. How many shoppers do we have in total? 200, right? Do we all agree to that? That is our denominator. Is that okay? And then how many of them were smokers with only high school education? 32. So the answer is going to be what? 32 divided by 200. Is that okay? Now let's get to the third one. What percent of shoppers with only high school education were smokers? So how many of the shoppers has only high school education? 93. Is that okay? And how many of them were smokers? 32. So it's going to be 32 divided by 93. Is that okay? Does that make sense? Good. If your percentages exceeds 1, it means, or it exceeds 100%, it means there is something wrong. Is that okay? These are not difficult. The only thing is that you have to be able to ask yourself, percent of what? Is that okay? You have to get the denominator right. Now, let's get to the fourth one. What percent of smokers had only high school education? So, what percent of what? Smokers. How many smokers do we have? 50. How many of them has only high school education? 32. You see? So you see, it's not hard. Is that okay? Good. We will come and do these later when we come back from Start Crunch. But what is important is to learn how to answer these questions. So you see, all that we did, you can find them here. The other thing I want us to do is that now we learned how to represent categorical variables using pictures or graphs. Is there a way we can also represent this contingency table using a graph? Yes. Is that okay? Graphs are very important. Imagine you are presenting and then you have a big data, you've summarized them. Graphs tells the information, so graphs give the total picture very quickly. Is that okay? So people don't have to look through or try to figure out the numbers. And so let's go to Start Crunch and load this data. Is that okay? So please open Pearson and let's go to Start Crunch and load this data. I remember last week I showed you how to load data. So please go to Start Crunch and then let's load this data. So I am in Start Crunch. Are you all in Start Crunch? Okay. So to be able to load the data, we go to data, load, and then we go to shared data set. So we go to data, load, and then we go to shared data sets. We click on that, and then we have this here. And then let's try to type in PD versus SM, and let's see. I think let's use this one. So click on this one, and then we have the data set here. Anybody struggling to open the data set? Okay, now let's try to represent this using graphs. So because we have two categorical variables, we can either use stacked bar graphs, or we could also use vertical bars to also represent them. So for example, let's go to graph. You go to graph, and then we go to chart, and then we go to columns. And then the question is asking us to select the columns. And so the columns here, when you look at the original data here, you can see that is smoker and non-smoker. So we try to select that. So smoker, and then I am using a Mac, so I just put my hand on command, and then I select this. So whatever you select, it should show here. So you see smoker and non-smoker. We have that here. And then the row is the year. So you see here, it's called year. You can see that from here. So that's the high school, 2-year college, and then the 4-year. And so we could use, I prefer vertical bars split. So we could use split vertical bars to represent this. And so when you do that and then you hit on compute, you see it shows this. Is that okay? And so you can see high school, the blue stands for the smokers, and then the red stands for the non-smokers. So you can see from here quickly that, oh, for high school, the non-smokers are more. Even for the 4-year college, the non-smokers has the highest count. So we could use this split vertical bars, or we could also use stacked too. If you want to use stacked vertical bars, you just have to go to graph, chart, columns, select the column correctly. If you don't select the right column, your graph would be incorrect or would not be able to give the meaning you are looking for. And then we click on this. You could also get vertical bars stacked. If you do this, you see this is horizontal. That's why usually I prefer vertical bars. This is horizontal. You could look for vertical bar stacked, and then it shows it this way. Is that okay? The other thing we can also do is to also let StatCrunch do some computations. We can also let StatCrunch do some computations that we want. So for example, if we want to display the row percent, the column percent, and the percent of the total, to be able to do that, you can go to Stat, and then we go to tables, and then we go to contingency table. What information do we have here? Here we have the summary. We don't have the raw data. The data has been summarized for us. Is that okay? Unlike what we did last week where we have the raw data. Here, the data has been summarized for us. So we go to stats, table, contingency table, and then we go to with summary. And then we click on that. Then we have this here. Same thing, select the columns, smoker, non-smoker. And what is the row? Year. What do we want to display? We want to display row percent, column percent, and percent of the total. And then we can click here. You see? It does it for us nicely here. Is that okay? So this is the row percent, column percent, and percent of the total. But in this class, I think that you just have to be able to understand that we can use vertical split bar graphs or horizontal or stacked bar graphs to do that. For this, I think you'd rather save time using the calculator than using StatCrunch. Is that okay? Because the question would ask you, just like you see in the PDF, what percent of shoppers with this? It's easier for you to see, oh, 200 divided by maybe 32 divided by 200, like that. So you are faster to use your calculator than going through StatCrunch to do all that. Any questions so far? Okay, so let's proceed. Now, the next question we want to answer is this. Do these data suggest that there is an association between smoking and education level? How do we answer that? So to be able to do that, let's try to compare the smoking percentages within each education group. Is that okay? So we are going to compare the smoking percentages within each education group. So for example, this is smoking. So for high school, we are going to do 32 divided by 50. Write the answer down. Is that okay? Same smoking, 2-year college, we do 5 divided by what? No, so for high school, we do 32 divided by 93. And then for 2-year college, we could do 5 divided by 22. For 4-year college, we could do 13 divided by 85. Is that okay? So to be able to answer whether there is an association between smoking and education level, we can compute the smoking percentages within each education group. So for example, let's get to high school. For high school, how many of them are smokers? The total number of high school students is 93. Is that okay? And 32 of them are smokers. We do that. How about 2-year college? What is their total? Their total is what? 22. How many of them are smokers? 5. Is that okay? How about 4-year college? Their total is what? 85. How many of them are smokers? 13. We just have to compute that percentages. And then if those percentages varies, it means that there is an association. So for example, you can see from here that we did that. This is high school, this is 2-year college, this is 4-year college. Now, because these percentages vary, it means that what? There is an association. And so this is what we did. So for each education group, the denominator is the total number of people in that education group. So for example, for high school, the total number of high school students is what? 93. For two-year college, the total number of two-year college students is 22. Same as for the four-year college. And then the numerator represents the number of smokers within that educational group. So you can see there is an association because these percentages what are different. Is that okay? So looking at these percentages here, what can you say? So you can see that it looks like those with more education, the number of smokers within more education, people with more education is less. Can you see that? Because now look at high school students, 34. Look at two-year college. Is that okay? So you can see the percentages are reducing. And then the more level of education, or the higher the level of education, the lower the smoking percentage. So it means that what? There is an association. Now, it is very important that you distinguish between association and causation. What information we have here is that there is an association, and we can see that, oh, the people with higher level of education have a lower percentage of smokers. It doesn't mean that more education causes people to stop smoking. Is that okay? So association does not automatically mean causation. It is very important. So we can only say that there is an association between smoking status and level of education. That is all that we can say. But we can never say that, oh, because there is an association, it means there is a causation, it means that if people have higher level of education, they are going to stop smoking. No. So it's very important that you note that distinction or that difference. So this is just a summary of what we did. What I want you to do now is let's look at this example. And then I want you to write on your note. Let's try to answer this question. Write what you think. It's very important that you write what you think. And then we will do it together in class. That way, even if you get it wrong, you learn how to do it. Is that okay? So this is an example. Take your time and read the problem, and then try to find the marginal distribution of eye color. And then find the marginal distribution of gender. Just do these two, and then we will discuss that, and then we'll do the other ones as we proceed. So first, try to find the marginal distribution of eye color. Before we do that, who can help us? What are the categorical variables here? Gender and eye color. Is that okay? Those are the two categorical variables here. Good. So now find the marginal distribution of eye color and then find the marginal distribution of gender. So some of you are doing very well. So when you're asked to find the marginal distribution of eye color, the first thing I want you to do, or I expect you to do, you have to locate eye color. Where is eye color? This is eye color here. Is that okay? What data did they collect on eye color? They did whether the eyes are blue. So you write blue, write brown, and then you write this. So we have three of them. Is that okay? So I expect you to write blue down, write brown, and write green, hazel, or other. Write these three down. That is the first thing I want you to do. Is that okay? We are asked for the marginal distribution of eye color. Step one, where is eye color? Eye color is here. Is that okay? And the eye color, we have blue, brown, green, or hazel or other. Write these three down. Is that okay? Does that make sense? Have you all written them down? So when you write them down, then we come. Now let's go to where you wrote blue. What is the total number of blue? 10. So you have to look through here and look at the total. You see? The total number is 10. Is that okay? So 10 divided by the total. 10 divided by what? 64. Then we go and do brown. What is the total number of people with eye color that is brown? 36. 36 divided by what? The total. Is that okay? And then the last one, we have you write green, hazel, or other. I expect you to write these three down. Is that okay? How many are they? 18. 18 divided by what? The total. That is how to find the marginal distribution of eye color. Any questions? I repeat again, anytime you're asked to find the marginal distribution of a variable, look at eye color. I come and look at eye color here. What do we have? Whatever we have here, write those ones down. Step one, that is the easy way to go about it. Is that okay? After writing them down, you come and look at blue. How many are they? They are 10. 10 divided by the total. Brown, they are 36. 36 divided by the total. And then green, hazel, or other, they are 18. 18 divided by the total. That is how to find the marginal distribution of a variable. Now, based on these, try to find the marginal distribution of gender. So as I'm coming around, I expect you to write those variables down, just like we did for the eye color. In this class, you can only learn by writing and practicing. This is statistics, and so you can learn better by writing and practicing. So try to write the marginal distribution of gender. So for gender, we find gender. This is gender here. Under gender, we have male and female. So you write out male and then we write out female. What is the total number of males? 32. You can see that from here. You see, this is male. You go this way, 32, divided by the total, which is 64. Female, 32, also divided by the total of 64. And so you get 50% for each. The other thing we want to answer is what percent of females are brown-eyed? What percent of females are brown-eyed? Anybody to help us with that? 50? Did you get 50%? Okay, so to be able to do the, you ask yourself, the question is saying what percent of females? How many females in total do we have? 32. How many of them are brown-eyed? 16. 16 over 32. Is that okay? Good. And then 4 says that percent of brown-eyed students who are female. What percent of brown-eyed students are female? Anybody to share what they got? 44 point. Did you get 44.4%? Good. So to be able to do that, what is the total number of brown-eyed students? 16. 36. Is that okay? The total number of brown-eyed students is what? 36. How many of them are female? 16. Is that okay? So 16 divided by 36. Let's get to the fifth one. What percent of students are brown-eyed female? 25%. The question is saying what percent of students? How many students in total do we have? 64. Is that okay? How many of them are brown-eyed female? 16. 16 out of 64. And then let's try to work this one out. What is the conditional distribution of eye color for males? So eye color, what is the conditional distribution of eye color for males? So to be able to do that, how many eye colors? We have brown, blue, brown, green, or hazel. We write that one out. Is that okay? So we come to blue. The question here has restricted you to only males. Is that okay? What is the total number of males? 32. Is that okay? How many of them are blue-eyed? 6. So we come to blue, 6 out of what? 32. Is that okay? We come to brown. How many of them are male? So 20. 20 out of 32. And then we come to green, hazel, or other. 6 out of what? 32. Is that okay? So that is how to go about that. And then you can also do the other one. Now, I want you to answer this. Does it seem that eye color and gender have an association? So try to answer that by yourself. And so when you look at the solutions here, we have, this is a marginal distribution of eye color. You see, I wrote that down, blue, brown, and other. And then I computed the percentages. And then I did for gender. Under gender, we have male and female. And then percent of that, I also did just like we discussed. You see, we have that one here. And then the conditional distribution of eye color for males, you see blue, given that they are males. What you just did is what I wrote here. Now, who can help us? Why do all three have a common denominator of 32? Exactly. So you see, because we are conditioning on being a male. Is that okay? Good. And so you can also compute the association. So for example, if you want to compute the association, so you come here. For males, we have 32 males, and then 6 of them has blue eyes. You do 20 divided by this, 6 divided by that, and then that is how this guy here is computed. And so because the percentages are varying across the various eye colors, you can see there is what? An association. Is that okay? Good. So sometimes what are the common mistakes students do? One, they can be comparing using the wrong denominator. Is that okay? And then also sometimes too, they could be, if they could be also overstating. So for example, we learned that association does not imply causation. If you try to imply that association implies causation, you are trying to overstate the conclusion. The other thing we want to talk about is Simpson's paradox. So what does Simpson's paradox do? I'm going to explain it in detail using an example. But what it's just trying to say is that sometimes when we look at the averages across different groups, they can appear to contradict the overall average. That is what Simpson's paradox is trying to say. So for example, the overall comparison is not the same as the within group comparison. So what is Simpson's paradox trying to do? To be able to do that, I'm going to ask you some questions, and then we will be able to understand what Simpson's paradox do. So let's look at this example here. Is that okay? So this example says that we have two pilots. The names of the pilots are Moi and then Jill. Is that okay? And then this is their day success rate, and then this is also, so it's showing their successful landing records. This is for day, and this is also for night. And then this is their overall. Now, focus on overall here. Who has a overall higher success rate? Just let's focus on overall here. You agree to that because you can see Mo has 83.3. Is that okay? As compared to Jill, who has 78.3. If you just say, oh, because of this conclusion here, it goes to say that Mo has a higher success rate. You could be wrong. Is that okay? Now, let's look at who performs better during the day. Let's just compare the day here. Who performs better during the day? Jill. Who performs better during the night? So you see, the overall is not depicting the entire picture here. Does that make sense? That is what Simpson's paradox is saying, is that sometimes the overall can contradict the within group averages. Is that okay? Or percentages. And so you can see, like you said, Mo has the higher overall rate, but Jill has a higher rate in both during the day and night. Is that okay? So that is what the Simpson's paradox mean? So you can see that more has many more. Why is it that they can be different? So for example, when you look at this one here, you see that more had many more day landings where success rates were high. You can see from here. And then this one also had more night landing where the success rates were low. You see. So the overall percentages can sometimes contradict the within group percentages. So that is what Simpson's paradox means. So what we've learned so far is that we know what a contingency table is. It presents the counts for two categorical variable. And then like we did here, we should be able to understand the contingency table better, learn how to find the marginal distributions of the various variables, learn how to find the various conditional distributions, and also learn how to determine if there is an association or not. And also always have in mind that association does not imply causation. So these are the things we've done today. And also have in mind that we can use split bar graphs, split vertical bar graph to represent the or to display the information on the contingency table. Any questions so far? Okay. So if there is no question, I will be putting the password on the screen soon. Let me try to